So hello everyone, my name is Rahana Binti Amirzaki and my student ID is 521013222110.
Hi, my name is Nuri Nazira binti Muhammad Kamal and my student ID is 521013222081.
Assalamualaikum and hi, my name is Nur Amira Nashuha binti Muhammad Ludin from L04.
Hey guys, my name is Nur Ainadira binti Muhammad Iza and my student ID is 521013222478.
So hello everyone, my name is Rahana Binti Amirzaki and today I'm going to teach you guys about De Morgan's law and also associative law. So before we start, I need you guys to remember two operations that we're going to use, which is conjunction and also disjunction. Conjunction is an operation for and disjunction is operation for or. So for example, we're going to start with De Morgan's law. For negation of conjunction and not P and Q, once you apply De Morgan's law, it's going to be not P or not Q. So remember, for De Morgan's law, you need to open the bracket and also you need to change the operations. For negations of disjunction or not P or Q, remember guys, open the bracket and change the operations. Therefore, not P or Q, once you apply De Morgan's law, is going to be not P and not Q. So I'm going to show you guys practice questions. Simplify the question not A and not B by using De Morgan's law. Remember, open the bracket and also change operations. So start with the given expressions, not A and not B. Once you apply De Morgan's law, it's going to be not A or B. Therefore, not A and not B simplifies to not A or B. So we're going to start next with associative law. So for associative law, you will notice that the operations, we're going to keep the operations, but we need to change the bracket size. So for conjunction and P and Q and R, once you apply associative law, you will notice that the bracket shift to a different side. So P and Q and R with associative law is going to be P and Q and R, and the bracket will be at Q and R. So for this junction, or P or Q or R, once you apply associative law, the bracket will be at Q or R. So I'm going to show you guys two practice questions, which is apply the associative law for conjunction and to simplify the expression A and B and C. Remember guys, keep the operations, change the bracket size. So start with the given expression A and B and C. Once you apply associative law, the bracket will be at B and C. So therefore, A and B and C simplify to A and B and C with the bracket located at B and C. So with a practice question, disjunctions, apply the associative law for disjunction or to simplify the expression x or y or z. So start with the given expressions x or y or z. Once you apply associative law, the bracket will be at y or z. So therefore, x or y or z simplifies to x or y or z with the bracket at y or z. So that's all from me.
Hi, let's answer a question about commutative and absorption laws. First of all, we start with commutative laws. The columns between P, Q, and P and Q represents the result of the logical AND operation between P and Q and between Q and P respectively. As you can see, every combination of truth values for P and Q, the values in the P and Q column are identical to the values in the Q and P column. This confirms that P and Q is indeed equal to Q and P for all possible truth values of P and Q, and the commutative law of logical AND holds. Next, we're going to answer a question about absorption law. The truth table confirms that for all combination of truth value of P and Q, the expression P or P and Q is equal to P. This supports the absorption's law, which states that the disjunction or of a proposition A with the conjunction and of A and another proposition B is equivalent to just A.
So here I'm going to tell you about the law of negations. So here, this is a negation and this is the symbol of negations. The negation symbols is a unary logical operator. It simply reverses the truth value of a given statement, such as denying, rejecting, and negating the ideas. So, if you see the table here, it says that the statement is F. So, if the statement F is true, then not F will become false. So, if the statement F is false, so the statement for not F will becomes yes, it's true. So if statement is represented as F, then not F is the logical opposite or negation of F. So this is for negations. So next is for double negations. So that's the symbol of double negations, same as negation, but you just plus another one. So the principle of double negation is based on the ideas that if a statement is true, then the negation of its negation is also true. In other words, if the start with a proposition as example F, the negation of F is not F, and the negation of not F is F. So F equal to not F, which is equivalent to F. So as you can see the table, so the statement F, the sky is blue. So when the statement F, the sky is blue, for negation, you need to reverse the meaning. So not F will becomes the sky is not blue. But for double negations, you need to reverse it back again to normal. So if the logic, you see the negation in bracket not F. So for double negation also have like a bracket not F, right? So you just look at the negations and just reverse it to another one. So the answer will be the sky is blue. So next we have the law of idempotent. So the idempotent law in logic is a principle that states that if you combine a proposition with itself using a specific logical operation, the result is the same as the original proposition. So in other words, applying the operation twice has the same effect as applying it once. So we have two main idempotent laws in logic, which is conjunction, it's and disjunction, or. So for conjunction, N, F, and F equivalent to F. This means that if you have a proposition F and you combine it with itself using the AND operation, the result is just F. So for example, if F is it rain, then F and F is it rain and is it rain is equivalent to is it rain, right? Okay. So next we have disjunction, which is or. So F or F equivalent to F. This means that if you have a proposition F and you combine it with itself using the OR operation, the result is just F too. So, for example, if F is it raining, then F or F is it raining and is it raining? I mean, is it raining or is it raining? Is equivalent to is it raining?
So I'm going to explain about identity law and also distributive law. So first, what is identity law? Identity law shows us that a proposition denoted as P is always equivalent to itself when combined with either true or false. It's like saying P or true is always just P and P and true is still just P. This law simplify expression and make logic easier to work with. So look at this question, which is identity law, P and T equals P. This law states that a proposition P and with the true T is always equivalent to P itself. Here the truth table to prove it. So when PT, TT, P and T become T, and when PF, TT, P and T become F. As shown in the table, regardless of whether P is true or false, P and T has the same truth value as P. So now look at the second one, which is P or F equals P. This law stated that a proposition P or with false F is always equivalent to P itself. Here the truth table for this law. So when P is T, F become F, P or F become T. And when PF, FF, P or F become F. So from the table, it's clear that no matter the value of P or F yield the same truth value as P alone. This law are fundamental is in logic as they help simplify expression and arguments. They demonstrate that a proposition with an absolute true or false does not alter the original proposition true value. So for the second law is a distributive law. So what is a distributive law? So this law states that if you have a disjunction or with one proposition and a conjunction and of two other, you can distribute the first proposition over the conjunction. This means you or it with each of the proposition in the conjunction separately and those result together. In this truth table, the first one table, the last two column P or Q and P or R and P or Q and R always have the same truth value for a possible combination of true value for P, Q, and R. This demonstration that the two expressions are indeed logically equivalent, which is exactly what the distributive law states. So for the second question, this law means that if you have a conjunction and with one proposition and disjunction or of two other, you can distribute the conjunction across the disjunction. This result is or the conjunction of a separate pair. So in this table, you can see that the columns for P and Q or P and R and P and Q or R has the same truth value for all possible combination of P, Q, and R. This confirms that the two expressions are logically equivalent as per distributive law. Okay, that's all from me.